Hello there. Today, we embark on a journey to understand a truly transformative technology called blockchain. You might have heard about it in relation to Bitcoin or other cryptocurrencies, but blockchain is much more than just digital money. It is a fundamental shift in how we can record and share information. Blockchain offers a mechanism for establishing trust without relying on traditional intermediaries. This is a powerful concept with the potential to reshape many industries. Throughout this discussion, we will break down the essential components of blockchain. We will look at how it works under the hood and why it has garnered so much attention. Its importance stems from its unique characteristics, offering solutions to long-standing problems related to security, transparency, and efficiency. By the end of this essay, you should have a solid grasp of what blockchain is and its significance in the modern world. We will explore its diverse applications and address some common misunderstandings. Understanding blockchain is becoming increasingly important as it is a foundational technology for the next generation of the internet. So let's begin this exploration. Let us unlock the world of blockchain together. So, what exactly is a blockchain? At its heart, a blockchain is a type of digital ledger. Imagine a shared, continuously updated record book distributed across many computers in a network. When a new transaction or piece of information is added, it is recorded in this shared book, making the information highly transparent. Think of a Google Docs spreadsheet where changes are seen instantly by everyone with access. Blockchain is similar, but with crucial differences. Once information is added, it is extremely difficult to alter or delete, a feature called immutability. This permanence builds trust and ensures the integrity of the recorded data over time. The shared immutable ledger is made up of blocks, each containing a batch of transactions or data. When a block is full, it is added to the chain of previous blocks, hence the name blockchain. Each block is cryptographically linked to the one before it, making the chain secure. Tampering with one block would require redoing all subsequent blocks, which is computationally very expensive. The core idea is a system that allows multiple parties to share a single source of truth without needing a central authority. This decentralization means that trust is built into the system itself and distributed among all participants. This is why blockchain is often called a trust machine, creating a reliable record transparently. Blockchain technology rests on several key pillars: decentralization, immutability, and transparency. Decentralization means data is distributed across many computers in a peer-to-peer network, making the system more resilient. There is no single point of failure, and the system is resistant to censorship. Immutability ensures that once data is recorded, it is extremely difficult to change or delete. Each block is linked to the previous one using a cryptographic hash, making tampering practically impossible. Transparency allows anyone to view transactions recorded on the ledger, increasing accountability. These three pillars create a robust and trustworthy system for recording information. Let's delve deeper into how a blockchain is structured. The fundamental unit is the block, which holds a collection of verified transactions or data. Each block contains three essential pieces of information: the data itself, a unique identifier called a hash, and the hash of the previous block. This chaining mechanism ensures historical integrity and security. When a new block is created, it includes the hash of the most recent block and is broadcast to all the computers, nodes in the network. The nodes validate the block and its transactions, and if valid, they add it to their copy of the blockchain. This process ensures that all participants have an identical and up-to-date version of the ledger. The chain grows longer as new blocks are added, representing the ongoing recording of new information. How are new blocks created and added to the chain? This is where the validation process comes in. It ensures that only legitimate transactions are recorded. When someone wants to make a transaction, they broadcast it to the network. Nodes collect these pending transactions and gather them into a new potential block. Before a new block can be added, it must be validated using consensus mechanisms. One well-known consensus mechanism is proof of work, POW, used by Bitcoin. In POW, specialized nodes called miners compete to solve a complex cryptographic puzzle. The first miner to solve the puzzle gets to propose the next block, add it to the chain, and is rewarded. Other consensus mechanisms exist, like proof of stake, POS, which requires participants to stake their own cryptocurrency to validate transactions. Regardless of the specific mechanism, the validation process ensures that all participants agree on the state of the ledger and prevents fraudulent transactions. Why does blockchain matter? The importance of blockchain lies in its ability to revolutionize trust. Traditional systems rely on intermediaries to establish trust, but blockchain offers a decentralized alternative. This decentralization enhances security by distributing data across many nodes, making the system resilient to attacks. Transparency on public blockchains can lead to greater accountability. For example, in supply chain management, blockchain can track goods from origin to consumer, verifying authenticity and preventing fraud. Blockchain's distributed nature also offers censorship resistance, empowering individuals by giving them more control over their assets and data. The combination of decentralization, security, transparency, and censorship resistance makes blockchain a powerful tool for creating fairer, more open and efficient systems. Blockchain technology is already being applied in various real-world scenarios. One significant area is supply chain management, where blockchain can track products from manufacturer to consumer, creating an immutable and transparent record. Another promising application is in voting systems, offering a more secure and transparent alternative to traditional voting systems. Healthcare is also exploring blockchain for managing patient records securely and efficiently. Blockchain can track pharmaceuticals, combating counterfeit drugs, and ensuring the integrity of the medical supply chain. Smart contracts are another powerful application, automating processes and reducing the need for intermediaries. These examples show blockchain's versatility and potential to improve various industries. There are different types of blockchains, each suited for different purposes. Public blockchains, like Bitcoin and Ethereum, are open to anyone and highly decentralized. Private blockchains are permissioned, with participation restricted to authorized entities. Consortium blockchains are governed by a group of organizations, offering a balance between public and private blockchains. The choice of blockchain type depends on the specific needs of the application. Public blockchains excel in trustless environments requiring open access. Private blockchains offer control and efficiency for enterprise use cases. Consortium blockchains provide a collaborative model for multiple stakeholders. Understanding these distinctions helps in evaluating how blockchain technology can be best applied to solve particular problems. As with any emerging technology, blockchain is surrounded by some common myths and misunderstandings. One prevalent myth is that blockchain is synonymous with Bitcoin. While Bitcoin was the first successful application of blockchain technology, they are not the same thing. Blockchain is the underlying distributed ledger technology, and Bitcoin is a cryptocurrency that uses a blockchain to record its transactions. Another common misconception is that blockchain transactions are completely anonymous. Most public blockchains are pseudonymous, with transactions linked to cryptographic addresses. A third myth is that blockchain is only about money or financial transactions. Blockchain's potential extends far beyond cryptocurrencies, with applications in supply chain management, healthcare, voting, and more. It is also sometimes believed that blockchains are unhackable, while well-designed public blockchains are extremely secure. The ecosystem around them needs careful implementation. We have journeyed through the fundamentals of blockchain technology. From its core features of decentralization and immutability to its diverse applications, blockchain presents a new paradigm for trust and data management. Understanding blockchain is becoming essential knowledge for business leaders, policymakers, and citizens alike. As the technology continues to mature, we will likely see even more innovative use cases emerge. The challenges, such as scalability and regulatory uncertainty, are being actively addressed by researchers and developers worldwide. The blockchain space is dynamic and constantly evolving. I encourage you to continue your learning journey. The more people understand blockchain, the better we can harness its potential for positive change. It offers tools to build more equitable, efficient, and transparent systems. The future of blockchain is being built today by a global community of innovators. In conclusion, blockchain technology represents a significant step forward in how we create and share value and information. Its ability to establish trust without central authorities opens up a world of possibilities. By understanding its core concepts and potential, we can all participate in shaping its future. Thank you for joining me on this exploration. The journey into the world of blockchain is just beginning. Keep learning, keep questioning, and keep building.